Good morning everyone. Once again welcome back in the next class of your chapter Simple Machine. In the last class we had discussed about what are the different types of machine, or what is the specification of a machine, how can a machine reduces human effort and relation between work and energy. In this class we will discuss about types of simple machine. There are different types of simple machine. One by one we will discuss about the different types of simple machine, but you should know about what are the different types of simple machine. Lever, inclined plane, and pulley, screw jack, wedge. There are so many types of machines. So we shall start with lever, then axle, inclined plane, pulley, screw jack. We'll discuss one by one about the different machines. Okay, so please carefully look at here and try to understand about the different types of simple machine. So first one is lever. Lever is a rigid bar that can move about a fixed support. Lever is like a simple and rigid bar that can move about a fixed support. After that we'll discuss about what is the meaning of fixed support. But lever is a rigid bar that can move about a fixed support. Okay, so it is a type of machine. Here we have a simple bar, that is lever. This is the example of lever. Here effort. Effort means from the point we are applying force. Means from the point we are applying our input force, that is effort. This is the load. Load means our output. From the point we are trying to do some work, means here we are trying to lift this heavy object, that is the load, means output work. From the point effort we are applying our load, and from this point load we are getting our output. And this fixed point, which we had already discussed, lever is a rigid bar that can move about a fixed support. This is the fixed support, and the fixed support is a fulcrum. About the point lever rotates, that is a fulcrum. So there are different classes of lever. We will discuss one by one, but before, it is very important, try to understand about effort, and here fulcrum, and that is the load. So first of all, effort is a point. From the point we are applying force. Load, this is the output work, whatever we want to as an output, and fulcrum is the point, at the point about which lever rotates. Suppose here we have one object and we are going to lift this object. Then this is the point. This is the point about which this lever rotates, that is the fulcrum. And from the point we are applying this force, that is the effort, and from the point this object will lift, that is load. Okay. So here by this line diagram we shall try to understand about the effort, fulcrum and load. This is the fulcrum about which lever rotates. This is the effort, and this is the load. There are different classes of lever: class 1 lever, class 2 lever, and class 3 lever. One by one, according to the position of fulcrum, load and effort, we shall try to understand about the different classes of lever. Okay. So first of all, just try to understand the basic diagram of this machine. This is the fulcrum, this is the effort, and this is the load. The distance between fulcrum and effort known as effort arm. The distance between fulcrum and effort, that is effort arm, and the distance between load and fulcrum, it is the load arm. So these are the basic and important points which you have to keep in mind. The distance between fulcrum and effort arm, and the distance between load and fulcrum, load arm. Okay, these are the important points which you have to keep in your mind. Okay, so this is the basic diagram of a lever. Okay, now one important formula which you have to keep in mind: mechanical advantage. I had already discussed in previous classes what is mechanical advantage. Just once revise it. Mechanical advantage is equal to load upon effort or effort arm upon load arm. Suppose if load and effort is given, then you can easily find the value of mechanical advantage. But in some cases, maybe effort and load arm length will be given. In this case, you should know this formula: effort arm upon load arm. Okay, by this you can find the mechanical advantage. So this is all about the basics of lever. Lever is a type of simple machine. Okay, it is a rigid rod which moves about fulcrum. It has three main important points: fulcrum, load and effort. Okay, so here there are different types of simple machine: class 1, class 2 and class 3 lever. On the basis of position of fulcrum, load and effort, simple machines means levers are divided in three parts: class 1 lever, class 2 lever, and after that we will discuss about the class 3 lever. Okay, so we shall start with class 1 lever. In class 1 lever, always fulcrum will be in between of effort and load. In class 1 lever, fulcrum will be in between load and effort. So here you can see in this diagram, fulcrum will be in between load and effort. Now we have to understand one thing: what will the values of mechanical advantage and what are the examples of class 1 lever. Okay, so here the fulcrum, it is not necessary fulcrum will exist always in between, means in center of these two lines, load and effort. It can be anywhere in between load and effort. Load and effort always will be sidewise, and fulcrum will exist anywhere in between these points, but it should be in between load and effort. So in class 1 lever, fulcrum will be in between of load and effort. In case of mechanical advantage, for class 1 lever, mechanical advantage may be greater than 1, less than 1 or equal to 1, anything. In class 3 lever, mechanical advantage may be greater than 1, less than 1 or equal to 1. Okay, there are different types of examples. Seesaw. Seesaw is the first example which you can see any playground. Fulcrum will be in between and one person will sit this side, another one sit this side. So you have seen number of times in different playgrounds. Seesaw is the first type of lever, means class 1 lever example. And the second one is pliers, scissors. Here you can see I have one device, that is scissors. By this you can understand about the class 1 lever. Here we are applying our effort, that is, so you can see here effort, and we are getting our output, so means we are getting from load here. So this is the second point, and about this point load and effort is working, so this is the fulcrum. So effort, fulcrum, and this is the load point. This is the first class of lever. So scissors are the example of first class lever. And we have another example, pliers. Pliers is also example of, so here you can see we are applying a load from here, sorry, effort from here, and this is the load, and here fulcrum. Effort point here, this is the fulcrum and load. So fulcrum is in between effort and load. Effort, fulcrum and load. So these are the devices which are example of first class lever. Okay, so in first class lever you can understand fulcrum will be in between load and effort, and mechanical advantage may be greater than 1, less than 1, equal to 1. Okay, it depends upon the value of load and effort. Okay, Next, class 2 lever. In case of class 2 lever, mechanical advantage always will be greater than 1. In class 2 lever, mechanical advantage always greater than 1. Okay. So here in class 2 lever, the load will be always in between of effort and fulcrum. In class 2 lever, load will be in between of effort and fulcrum, and mechanical advantage greater than 1. So this is the case of class 2 lever. Some examples of class 2 lever: nutcracker, wheelbarrow. Wheelbarrow is a device by which we can move one object from by this wheelbarrow we can use to raise one object from one place to another place. Okay, and nutcracker is a very famous device which is used to crack the nuts. Okay, so I will show you the second class of lever, that is nutcracker. So here you can understand effort from one end, fulcrum another end, and load will be in between. So you can see here, this is the fulcrum. So about which load and effort are working, that is fulcrum. So this point fulcrum, and here we are getting the load. In this point we are getting load, and we are applying effort from another end. So fulcrum, load and effort. So we can say load will be always in between fulcrum and effort. So it is a class 2 lever. There are so many devices. Wheelbarrow. Okay, you can see this example of wheelbarrow in your school and colleges. Sometimes it is used to displace one object from another place. Okay, so this is all about class 1 lever and class 2 lever. Class 2 lever, load will be always in between fulcrum and effort, and mechanical advantage greater than 1, and this device used as a force multiplier. Class 2 lever is used as a force multiplier because mechanical advantage greater than 1. Okay, so now we'll discuss about the class 3 lever. In class 3 lever, mechanical advantage always less than 1, which we will see here. In class 3 lever, effort will be always in between load and fulcrum. In class 3 lever, effort will be in between of load and fulcrum. So this we can say, in which case effort will be in between fulcrum and load, we can say that is the class 3 lever. There are so many examples of class 3 lever: fishing rod, tongs and broom. These are the examples of class 3 lever. So mechanical advantage less than 1 means we can say effort, we know that effort arm upon load arm. This is the formula of mechanical advantage. So if the value of load arm will be greater and value of effort arm will be less, so mechanical advantage will be less than 1. So in this case we can see here we have one more example. This is the example of class 3 lever, tongs. We are applying our effort in between. If we have to hold something, if we have to hold this object, so we are applying our effort in between of, this is the fulcrum, this point about the fulcrum, and we are applying our effort from here in between, and this is the output one, means our load is working here. Okay, this is the fulcrum, effort, and this is the load. So effort in between of fulcrum and load. So we can say this is the example of class 3 lever. Okay. So by this we can understand about class 1, class 2 and class 3 lever. So this is all about first type of machine, that is lever. Okay. in the next class we'll discuss some other types of machine like inclined plane, pulley, wedge. There are so many. So please revise it once again. Then only you can understand about the concept of simple machine. This is one of the most important point and topic of your this chapter, because we have to solve different types of numerical problem on this topic. Okay, so once again revise different class of lever, class 1, class 2 and class 3 lever. So when we will meet in the next class, we'll discuss about the other types of machine. So thank you for today. We'll meet in the next class.